Hello, everyone. I am Mariz Ortega, and I am from De La Salle University, Manila, in the Philippines. And for today, I will be sharing with you our topic that we studied in one of the basic education division high school in the Philippines. So this topic has a title of Understanding of the Periodic Table and Attitude Towards Learning Chemistry, Effect of Mental Models of Periodicity Through Guided Inquiry Approach or GIA. Together with me is the co-author Biching Ong Uiki and Kok. So this paper has four parts. So these four parts has first the problem area and the objectives, methodology, results and discussion, conclusions and recommendations. For the problem area, most of the pressing concerns that teachers observe among their students is that chemistry students find chemistry too abstract and mathematical, which makes it hard for them to understand. There are certain literature and studies that also supported that when students are only faced with different theories, numbers, and facts without certain representations, hinders their understanding of the certain topic. To be more specific, in chemistry. Now, when students have a hard time in understanding these topics without any representation, it further moves them towards having a negative perception or attitude towards learning chemistry. So, this results to the different efforts of really understanding how students create their thought process to be able to help them understand further these different topics in science, particularly in chemistry. Hence, the rise of mental models. Mental models, these are mental representations that students create on the spot when they are given a certain activity or when they are faced a certain topic to learn. So, why mental models? This paper focused on the use of mental models of periodicity through guided inquiry approach. This is an offshoot from my own observation in my classes, wherein students use TPS or Think Pair Share structure or Think Pair Share strategy. However, one of the questions in using Think Pair Share strategy is that are students really sharing correct ideas with their pair or with their classmate? Or what is the thought process that students are integrating in specific understanding of the lessons and of the answers to the questions that they're trying to share with their partner? There are different literature that supports the use of Think Pair Share strategy. So, Think Pair Share activities further help students develop their cognitive skills. This is because of the reason that students benefit when they discuss the answers first with a partner. So, in different arguments and in different articles, there are certain recommendation that students' mental models are a target for correction and expansion. However, how do we really characterize and how do we really identify student mental models? There are several tools or ways to assess students' mental models. It could be either through open-ended interviews, think aloud protocols, concept mapping, and other types of strategies that will allow and give data to teachers on how students really create their representations while learning the topic. So, most of the literature suggests using one day activity to be able to identify students' mental models. And this one day activity only uses think aloud protocols, recorded conversations. However, even though they were able to create such one day activities for students, there are still misconceptions associated with periodicity concepts. These periodicity concepts, such as electronegativity, ionization energy, and even chemical bonding, arise even with the use of mental models. Hence, there is a stand for a recommendation to not just use one day activity but rather scaffolded activities. These scaffolded activities will really allow students to gradually dig deep into using their mental models. Therefore, the use of guided inquiry approach is a really good strategy in making these scaffolded activities for the students to fostering this positive environment for them to learn new things. So for the research problems, the focus of this paper, it is sought to really identify or to really answer the following questions. What really are the characteristics of student mental models of periodicity as revealed in their performances in the following GIA activities? So this paper will use different GIA activities that is alongside with computer-aided instruction, such as PhET simulation, periodic table completion, and interactive periodic table. Will there be a significant difference on the understanding of students' periodic table before and after the GIA activities, as well as their attitude? So for the methodology, the research locale and participants um, involved or employed in this study is in Assumption College Basic Education Division in San Lorenzo Village, Makati City, Philippines. It involves all grade 8 junior high school Aghamon students, which are 37 students. These Aghamon students belong to advanced class students. So for the research instruments, mental models of periodicity activity sheets, which is teacher made, as well as model checkpoint activities. PT80, adapted from the Merclio and Calic in 2009, as well as Attitude Towards Chemistry Lesson Scale, adapted from June 2007, alongside with one-on-one interview and classroom observation for triangulation method. So for the methodology and for the flow of the procedures employed in this study, the first thing is to employ a pretest. So pretests were given to the students on the PT80 and Attitude Towards Chemistry Lesson Scale. Now, after the pretest, students are now given a chance to learn the unit about periodicity or about periodic table, which involves GIA activities. These GIA activities are divided into three: build an atom activity, which is focusing on atomic structure, periodic table completion, and periodic trends activity. Alongside with this particular activities or GIA activities in class, the teacher or the researcher will be able to identify the characteristics of their students' MMP and attitude through the recorded Think Aloud protocol and model checkpoint activities given at the end of each topic. Now, it is further anchored in characterization of the models or the representation based on the Johnson's triangle of chemical representation, wherein students' mental models are classified as macroscopic, microscopic, and symbolic. After which, or alongside with it, there are simultaneous one-on-one interview and classroom observation. And the last step is post-test. For the outputs, results, and discussions, to answer the first question on the focus problem of this paper, again, it is anchored on Johnson's triangle of chemical representation. So it is based on the characteristics of each category or the description of each category for macroscopic, microscopic, and symbolic. Macroscopic, what students observe, what students see and explain. Microscopic, when students develop their own model already on what they understood on the topic. Symbolic, when they create certain labels of what they learned about the topic. So these are some of the outputs of the students in the Build an Atom activity. So microscopic, so for this particular activity, students were able to characterize their mental models as microscopic, symbolic, and some of them has a combination of mental models. As you notice, in the microscopic levels, the students created different models by using shades and circles to represent atoms and subatomic particles. Whereas for symbolic, students now start to put different symbols for electrons, for protons, and even for neutrons and the energy level. Whereas for combination, some students integrated microscopic together with their symbolic representation. Same thing that happened with the other types of activities in the lesson. Another very interesting observation or output of the students is that one student were able to create a model that is affected by her prior knowledge, as also supported by the study of Criswell in 2007. In this mental model, or in this particular representation, the student were able to integrate her prior understanding of the energy levels, which is shown by this diagram. Another observation is for the expansion or the correction of students' understanding of different concepts. So one of the misconceptions that arise based on the student's model is the position and the number of electrons present for each atom, which is further corrected all throughout the learning activities. So this is another work from the students that falls under macroscopic, microscopic, symbolic, and even combination. So as you notice, majority of the students falls under the microscopic chemical representation or mental models of periodicity. So these are the key takeaways on the characteristics of students' MMP. Most of the students falls under microscopic representation alongside with overlapping and integrating other mental models of periodicity. There is integration as also supported by the study of Sanchez and Munter in 2017 and 2020 respectively. It is also influenced by prior knowledge, and there are corrected misconceptions based on the model. For the second question, will there be a significant difference in their understanding? So based on the quasi-experimental design using t-test on the pre-test and the post-test paired sample, there is a significant difference on the pre-test and post-test result of the students, as also supported by the effect size. So the Cohen's d gives us the understanding that there is a very large effect size. So the Cohen's d value is 1.18117. So this is also a graph showing the increase in the students' understanding of the periodic table. So these are the key takeaways on the second problem. There's a significant increase. There's a very large effect size in the study. And the use of various application, GIA, increases their success and interest in the study of chemistry, which is also in consonance with the study of Sanchez in 2017. So the exposure to MMP representation enhances their performance as well as computer-aided instruction. So for the attitude towards learning chemistry, so as you can see, there's also an increase in the students' attitude towards chemistry. So one of the supporting details is that the use of GIA activities and sharing with their partner creates a positive environment because students feel more confident in understanding and in sharing their understanding about chemistry topics. Also, the use of virtual laboratory applications such as the PhET simulation. So these are some of the transcribed one-on-one interviews with the student. At first, the student find it very confusing and it's affected by her experience in the previous school year wherein she got a low score. But now that she was able to create representations or models, she views it differently. For the conclusions and recommendations, most of the students are in the microscopic level. There is an improvement in the understanding as well as improvement in the attitude. For the recommendations, explore the use of other GIA activities and materials. Maybe there might be some revisions on the guide questions and materials to further enhance students' MMP. Possible improvements on the GIA activities aside from the use of PhET simulation and interactive periodic table. And it can also be used in other topics than periodic tables such as chemical reactions, stoichiometry, and molecular geometry, and used in multiple case studies of different teachers teaching the same level. So that ends the topic about understanding of the periodic table. I hope you learned something new and thank you for listening.